All right, this is a video lesson for Unit 3, Lesson 1, which is one-step equations. So we're moving into solving linear equations, and we're going to start off really easy with one-step equations. We're just going to look at one thing to do in one of these problems and how we can solve it. So the target today is I can solve one-step equations using inverse operations. This is a big term, inverse operations. Our vocabulary that we're going to use. All these are key if we're talking vocab. So the first one's an equation is a statement in which two expressions with an equal sign between them. So any math that you see, 3x plus 4, something like that, this is an expression. But as soon as you throw in an equal sign, maybe a 7 or something over here, now you have an equation. Equal sign means equation. A solution is a value that makes an equation true. So if I have something like 2x equals 4, the solution would be x equals 2. If I plug 2 in for x, I get 2 times 2, which is 4. So it makes it a true statement. So it's anything that you can plug into the equation to make it true. Inverse operations is the method we use to solve. So inverse means to undo something. So these are all operations that undo each other, and we're going to list those out in just a minute. This allows you to isolate a variable, which means get the variable alone, and then in order to keep an equation balanced, which is another thing we'll talk about, whatever operation you do to one side of the equation, you must do to the other side. So those are just some key vocab terms that you're going to hear us discuss throughout this lesson. Inverse operations. This is the big thing to learn if you're doing one-step equations, which is what we're doing today. Addition and subtraction are inverses of each other. To undo addition, you subtract. If I start with x and I want to get back to x, well, let's say I start with x and add 5. The only way to get back to x would be to subtract 5, because these two guys go away and leave you with x. Multiplication and division do the same thing. If I were to take x and I want to get back to x, so if I have x and I multiply it by 2, to divide it by 2 would cancel out the 2's and you would just be left with x. So addition and subtraction, they're like sister operations. They undo each other. And same thing with multiplication and division. They undo each other. Inverse operations. So we're just going to do some really quick and easy examples of each of these things. If you're feeling like you can do these problems on your own, do it, and then come back and check your answers. But these should be problems that you feel pretty comfortable about. In this problem, we have an adding of 4, keeping x from being by itself. So the way we're going to undo that is by subtracting 4. But if we do it to one side, we have to do it to both sides. In this case, the 4's go away because 4 plus negative 4 makes a 0, so it's just x left on that side. And on the right side, 8 minus 4 equals 4. And we're left with a solution of x equals 4. In the next problem, we have x minus 24 equals 17. Well, we want to get this x by itself, so we want to get rid of that minus 24. So the inverse operation of subtracting is to add. So we're going to add 24 to both sides. Well, this is really just going to make a 0 and make that negative 24 go away. So we're left with x. And on the other side, 24 plus 17 makes 41. And that's our solution to that problem. Really similar things going on for multiplication and division. You might be confused with multiplication because you're not seeing that little dot that's there. Okay, you don't have to write it. 5x means 5 times x. So how do I get rid of multiplying by 5? I have to divide by 5. And if I do it to one side, I have to do it to both sides. So over here, the 5 and negative 5, they make a 1. And 1 times x, the 5 and the divide by 5, they make a 1. And 1 times x just equals x, so we've got an x alone. And over on the other side, negative 30 divided by 5 makes a negative 6. And that's our solution. For number 4, This fraction bar means division. So if you're confused by that, let's make a little note. This means division. So we're dividing by -7. Well, if we want to get rid of dividing by something, we want to multiply by something. So we're going to multiply both sides by 7. When you multiply to the top. So I'm going to multiply this side by -7. I'm going to put it in parentheses so you don't get confused and think it's subtracting. So the -7 and the -7, they cancel out because when you multiply and divide by the same thing, nothing happens, inverse operations. And then I'm going to multiply this side by a -7 too. We're left with x equal to 3 times -7 is -21. Now we're going to move into some more challenging examples. These are the reciprocal problems. So we have -2/3 x equals -12. The first thing I would recommend is rewriting the problem and moving the negative to the top of the problem. I think it just helps. You don't have to do this, but I think it definitely helps people understand. Okay? One thing you might want to do as well is realize that a -12 is really a -12 over 1. Dividing by 1 doesn't do anything, so it's okay to write it so that you understand that this is a fraction with a top and a bottom. You'll see why that helps in a minute. In order to get rid of this 3, because we're trying to get x alone here, in order to get rid of this 3, what we want to do is we want to multiply by 3 because we're currently dividing by 3. Remember, this means division. So we're currently dividing by 3, so we want to multiply by 3 to the top to get rid of that 3. That would get rid of this 3, which would be great. The issue is we'd still have that -2. To get rid of this -2, we would want to divide by -2. So what we're going to do is we're going to do both. This is called the reciprocal. The reciprocal is to take a fraction and flip it. This is what we're going to do whenever there's a fraction, like this, in front of our variable x. So we're going to take the fraction and flip it to 3 over -2. This is going to make the 3's cancel each other out, and the -2's cancel each other out, just leaving you with the x. On this side, the right side, we're going to do the same thing. We're going to multiply by that 3 over -2. That's going to become -36, because I'm going to take the -12 times the 3, -12 times 3, and that's -36. And the 1 times -2 is going to make a -2. And when I simplify this, I'm going to get x equals 18, because -36 divided by -2 equals 18. And that's our solution to this equation. X equals 18. So we're going to do this very similarly for the next problem. Automatically, when you see a fraction in front of the variable, you should just flip the fraction and multiply that to both sides. That's the procedure. But again, the understanding reason, if I want to get rid of multiplying by 3, which is what this is, I want to divide by 3. If I want to get rid of dividing by 4, I want to multiply by 4. So I really want to multiply that side by 4/3. But to keep things balanced, I have to do it to both sides. So I'm going to do 4/3 over here as well. And it's really a little 9 over 1. The 4's cancel, the 3's cancel. We're really just left with this x. X equals 9 and 4, multiply top by top, that's 36, divided by 1 times 3, that's 3, and 36 over 3 is 12, giving us an answer of x equals 12. And that's it. That's our entire lesson for this material. One step.